So this is, are you all set? Good to go. All right. So we've got a whole crew of folks up there. I'll let you all introduce yourselves, and so hopefully we can just go and get started. And is Steve in the room? Okay, perfect. Actually, so just before we get started here, I wanted to recognize Steve. Steve is from Big Switch and is the project lead for our Open Network Linux project. And one thing I called out this morning, right, was that a lot of the different projects within OCP, the software projects, SciSonic, ONL, ONI, are really driven by passionate members of the community who devote their time to open source. And so we really wanted to say thanks to Steve for his support of Open Network Linux. Right? Thank you. Thanks a bunch. So with that, I think that's the setup for you all.
I start with the mic, so I guess I introduce myself first. So I'm Rob Sherwood. I work at Facebook on the Fboss team.
Hello, my name is Vivek Shah. I lead the Switch platform team at Google.
Kyle Forster, one of the founders of Big Switch.
Darren Hutchinson. I work with Vivek on the platform software for our switches.
My name is Jeff Townsend. I run the software switch teams at Big Switch.
So as we get started here, how many people had the chance to see the short talk that we gave yesterday? Sort of, okay, good. So this will be, we're going to interleave. Think of this as sort of the double click down. And let me start with, between yesterday and today, we still believe that networking is in a renaissance. And this is a wonderful thing because unlike the group yesterday, right, where we have a lot of people from non-networking backgrounds, I think for us, our hope was to make this session much more interactive because this is the group that we think is going to take networking to the next step. This is the at-scale community here in this room. I know I look around and see an awful lot of familiar faces. And it's just a wonderful thing for us, I think, for all of us to be here.
So I'm assuming most people saw the talk that Kyle mentioned. The high level is we all have very different visions of how to run our networks. So hopefully folks have maybe heard of the Fboss work that my team has done. It's open source. It's one very specific view of how to run the network. It involves, all right, well, we're still going to run BGP on top, but maybe we're not going to run BGP. Maybe we're going to swap in our own routing protocol. We're still going to have distributed protocols that talk to each other in much the way you might think, but we're going to have a centralized database that manages what all the network state's going to look like, and we're going to statically generate all of the running config equivalents. That's a thing that works for us. And it doesn't work for my colleagues. They had different ideas of how to do things. Talk about the Google bits, just in short.
Yeah. So as we announced yesterday, we have a P4-based SDN controller, but still there is a lot of commonality with the use case of using Open Network Linux, and we kind of have been working with Big Switch Network to enhance Open Network Linux, and those are some of the details. Me and my colleague Darren will talk more about what those enhancements are and what our plans are. So ONL is very strategic to us, and we believe Statum plus ONL, Statum plus ONL will combined will enable white box switch vendors.
I think our goal on the ONL side is to create an abstraction layer across many, many different switch hardware platforms. I think as of yesterday morning, Steve mentioned that we're now up to 70 switch hardware platforms in our ONL regression testbed. So when we can abstract away more and more pieces of software from dealing with everything from spinning the fans and taking the temperature all the way to how do you do some of the kind of the hairier side of process management for ISSU, there's a lot of value we think that can be provided by a broader open source community around ONL that lets more and more pieces of software kind of innovate independently from underlying hardware platforms themselves. I think coupled with that, our demo is really focused on work that's currently in flight, around threading the netlink listener in ONL all the way through to hardware, so that we can use higher layer Linux software packages. I mean, the most obvious one being FRR, but there are some interesting others. On top of ONL, on top of the whole plethora of different switches. We think that FRR is particularly interesting for this crew because the number of organizations out there ready, willing, and able to write their own controllers from scratch, to write their own routing protocols, that's a small group of end users in our community. However, the group that's looking to orchestrate Linux boxes that speak BGP, we believe that is a much broader group. Is that the entire enterprise group? No, not at all, but that is kind of the broader OCP membership. So we think the work that we're doing around extending netlink, around creating kind of clean distributions with FRR on top of ONL for all of the ONL hardware, dramatically expands the aperture of people interested in ONL from the group of 5 all the way out to, I'd say, most of the organizations represented in this room today.
Sorry, I got to check the slide. So why bother, right? I mean, really the question is why bother? And of those here that are interested in or familiar with the open networking boxes, can any of you name a forwarding ASIC that is on any open networking box? Doesn't matter which. Anybody know any of the names of any of the Broadcom forwarding ASICs on any of the opening? Tomahawk, there you go. All right. Raise your hand if you know what fan controller is on any of these boxes. What kind of PSU is in the box? How many different kind of temperature sensors they might have? What the device tree looks like for some PowerPC processor that's on some box you don't care about, right? So the key part for ONL is there's not a lot of innovation in the platform management part of all these boxes. And it used to be, somebody would have to go build the box and some guy there has to go build the fan controller and write software for the thermal plan, and somebody has to go figure out, how fast the fans have to run at what temperature when all the ports are powered up, and nobody cares about that except the guys that have to build the box, right? And so when open networking really started, you'd find everybody who wanted to do their own OS for this has to go and do all that stuff first, right? They got to go get a data sheet from Acton or DNI or whoever makes the box, and they get the thermal plan and go implement it, and then go figure out how to talk to the SFPs, right? Your data plane wants to know what kind of SFPs are plugged in, but you don't really care how many I2C muxes are on it, and it's just da-da-da-da-da forever. And everybody has to do the same thing over and over again, right? They're all the same boxes, they're all the same topologies of the hardware that are on them. Everybody has to write the same code to access the same things, and it's just a waste of time. So when Big Switch started deploying on open networking boxes, Cumulus starts deploying on everybody has to start doing all this work over and over again. So we said, let's not do that. So let's take the work that we have to do that has everything to do with managing the box and make that available for free as a platform. And then get everybody who designs the hardware, who knows all of that stuff better than we do, better than you do, so that you don't even have to do it. Eventually, the hardware vendors push all that code into the project, and then all of that stuff just magically appears and is available to you as a starting point for you doing your data plane special sauce. That's really the vision, and that's really why. So create a platform that works on all of these. It's really a development environment and a runtime environment that works on all of these open networking switches as a starting point for you to decide whether you want to run BGP, whether you want to run your own custom proprietary routing protocol, whether you just want to do an L3 stack only. So all of the special sauce and all of the innovation has to do with behaviors of the data plane, not behaviors of the fan speeds. So, and that's why we do it, and that's why we think it's powerful.
I think just to give you a quick sense, while ONL is taking care of a whole layer of device drivers that normally sit under the surface. I think this is a quick video that Steve put together that we thought was just very cool. I mean, it just shows an Acton and a wedge sitting side by side. And you just see the nice normalization of hardware components that in a software engineering schedule, so many people who are setting out to build their own switch OSs just forget about. And having a normalization layer here, we believe, will drive innovation in this industry further, faster, because do we really need to write the world's 40th I2C driver and the world's 50th fan driver? Our industry can move beyond that.
Just to give credit where it's due, a lot of this is actually due to the software engineering work that Jeff did, which is why we dragged him up on here. So thank you for coming up for that. Also, in terms of how well this works, if you want to understand what various ODM vendors are shipping and what's going to be on their roadmap, take a look at the O&L commit tree. Generally, the drivers will land before the product announcements. That's how efficient this has started to get. But on that note, all right, so I'm from Facebook. I'm up here. What is Facebook using this for? So Facebook has been very, very public about using OCP hardware in our data centers. We use that in production. It's an everyday thing. It's great. We don't actually use O&L in our production. We use, one of the values for us of having an open hardware platform, the thing that works best for us, is to use the same Linux distribution that we use on our servers, on our switches. And library for library, binary for binary, we try to make those as close as possible because it just simplifies our lives operationally. That said, there's actually a growing number of use cases where we need to have Fboss, the software that we've built and run outside of what we would call the production area of the network. And then when I say production, really what I mean is one specific security zone, even though we might use it in other production-ish cases. For example, doing lab development, vendor integration, bug reproduction outside, trying to bootstrapping into production. There's actually a bunch of important use cases where it turns out that if you're a NIC vendor and want to validate that your NIC works with the Fboss switches, up until now, you actually couldn't do that. Like, you couldn't get a copy of Fboss running outside of our data centers. And so this is actually solving a pretty big problem for us. That's you.
The problem that O&L solves for us commercially, right? If you think of the O&L part of our company is for the OCP, the hyperscale, the at-scale community, and if we think about the enterprise side of our business, O&L is part of our supply chain. Our enterprise business, our software runs across the Dell Open Networking line, across the HP Alto line, across the EdgeCore portfolio. We have called 3 sort of major fabrics. We have a switching fabric software load, we have a monitoring fabric software load, and we have an inline security fabric software load. And so for us, this problem became, okay, how do we, across the different fabrics that we support in production, and across the different hardware options that we support, how do we create a normalization layer there? This for us, our different fabrics drive the ASICs completely differently. And so we needed a normalization layer outside the ASIC that for us turned out to be critically important. So for us on our commercial side, Open Network Linux turns out to be a very critical ingredient of our enterprise commercial side of our business.
So yesterday we talked about Google's vision for next generation SDN switch, and I mentioned it needs to provide ASIC and a system level abstraction. And there are 3 main pieces we're looking to realize that vision. We are betting on P4, we are betting on OpenConfig, and we believe O&L will provide the needed system level abstraction. Now, what made us attracted to O&L? We'd like to hear from Darren.
So I actually started this. We sort of said, well, we want something like this. Where can we find it? So we went out and looked at what was around. And O&L really, and ONLP especially, really sort of stuck out for us. Because there's a real hardware abstraction behind it. It really does insulate you from the hardware. And what was important to me is a lot of that non-switch plane information, like how hot things are, how fast they're running, it sort of really seemed to be given lip service in a lot of the other alternative operating systems. Whereas ONLP especially was very comprehensive about it. We're getting very good information out of it. And behind that, there's also a structured hardware model. And one of the things that I really liked about it was we spent a lot of time generating configurations for things. And this was a chance where we could basically take a switch and say, why don't we learn from the switch what its hardware is? You know, why are we even in the business of thinking about that? And the other thing that's really small is underneath it all is a really standard Linux. I mean, it's very little oddball about it. We're not dealing with BusyBox. We're not dealing with BusyBox. Everything just works basically the way you'd expect it to. And that really helped us get the demo out quickly. Oh, I'm going to do all of them. All right, so as I said, we were actually really quite surprised at how comprehensive it was, especially compared to some of the earlier ones we looked at. There's but there's a few things that we wanted to do to it to help it in sort of Google's environment. And there's a lot of things you don't think about. You know, everyone thinks about switches as forwarding packets. But as Kyle mentioned, and actually everyone mentioned, there's a huge amount of work in just dealing with those little details. So there are a few things we wanted to do. We wanted to actually have a fan tray, for example, as a concept. We wanted more out of the SFPs. We wanted more asset information because as data centers get larger, you end up tracking the silliest things. and the example I tend to use is the fan tray. Why would a fan have a serial number? Right? Well, if you've got a couple 100,000 of them, you work it out pretty quickly, because we need to keep track of all these things. And just they were the little bits we needed to add that they hadn't thought of, which was really impressive. And a lot of little things. There's no point going through the whole list, but just to say we're actively working on making this better. It's very close to what we want. And just to sort of put that in a more concrete form, one good way to really work out ONL is just to try and do something. And so I got put together a full stack demo. We've got some software around. It'll work. You got a couple of weeks. And there's a couple of things I'd say. The development environment's really very quick to set up, very productive. I was actually surprised at how little we actually needed to tell our software about the switch because of ONL. We just didn't care about it. My feeling personally is that a port to another white box type switch would actually be very, very quick. I mean, there's still, we still have to bridge that divide between the data plane information and the other platform information. But, it was very, very close. We actually had very little trouble with the data plane side of it. And just to sort of bring out a power of this a little bit. So I started sort of really looking at this about 4 or 5 weeks ago to get the platform ready for this demo. And we were able to do that. And get an existing switch stack on there very, very quickly and with very little effort. I'd say personally, if I exclude the one-off work for OCP, for ONL in the first place, it was really about 2 or 3 man-weeks of work to bring the actual software onto a platform once you've done the basic stuff, to bring it onto another platform. And that was really, really impressive to us because we spend much more time than that doing what we do now in terms of building switches.
I think for us, it's very important to note that the theme of this OCP is open for business. And when we were first talking with Bill about this session, Bill asked to say, hey, can we show that OCP technologies and the OCP networking track is having influence not only in that scale community, but in the broader enterprise community. If you look at the work that we're doing together of open sourcing ONL, putting ONL on top of many, many switch platforms, extending ONL for different key use cases. It's a beautiful thing to watch the role that OCP and the OCP membership in this room is now playing in the broader enterprise market. And we're incredibly excited because ONL can be easily embedded into commercial products. It's being run in production in financial services networks, in very large-scale NFV networks, in IoT networks, in autonomous vehicle networks, in some of the most secure and most private of the private clouds in the industry. It's an exciting set to watch OCP networking technologies influence the broader market in this way.
All right, and so with that, actually I think we'll just skip to the demo in interest of time, is what I'm thinking. What we're going to do now is play effectively the same demo, but instead of like the smoke and mirrors, we're actually going to tell you what's going on under the covers. So one of the things that we did working with Big Switch was we ported our Fboss software to work on top of Open Network Linux. Now this is work in progress. But what we're seeing here, that didn't work at all. Let's see. All right, so what we're seeing here is, somebody's logging into a box. You could tell by the motd, the message of the day, that it's Open Network Linux. More importantly, there's the dump of ONLPD, which is actually showing you the abstraction of the fan drivers. The critical thing here is you can run that same command on 70 different switches and get their version of that same information. And it may not look like much. Like you're like, I get this information all the time. Every switch that you've gotten out of, that information out of, like probably something in the order of 3 to 6 man-months got lost because of that, times every operating system that got ported to it. And usually historically every switch has only had one operating system ported to it. Like it's a vendor device, the vendor operating system got ported to it. In the open network context, that's not the model we're working towards, and this is kind of a new and important problem that we think we've got a good solution for. But so what do we do past that? All right, well, now we've got standard Fboss commands. These are the commands that I type every day trying to debug switches. Folks from the Fboss team will smile and laugh and see some of the output here. We generate our configs with JSON. We generate them one time. This is a config that's up and running on an open networking switch outside of Facebook. We use we have our own RPC protocol, Thrift, that speaks directly to Fboss. We use it both from the command line, but more importantly, all of our routing agents also speak Thrift. So the work for us to remove BGP and drop in OpenR is actually trivial because we don't have to change the Fboss agent. We just change the calls that are being made to it. And it's a completely different way of looking at your network. And I keep hitting the button that makes it go the wrong way. And yes, of course, in a demo, you have to show that ping works. Hopefully that's not too surprising for folks. Even less surprising is that this is running at line rate. But it's important to show because it's pretty easy to set up a demo that doesn't do this. We'll be able to answer technical questions about this afterwards, but I'll hand off to the next folks in line here.
So how many people here work for end-user organizations where you feel like you're ready, willing, and able to write your own protocol stacks? Rob, you've got to raise your hand.
I don't even work on that team.
It's a very, very important number, but it's not the majority of this room. It's our belief that the majority of people here are very interested in 3- and 4-tier BGP classes. And you probably have a very unique way to manage those classes. So not to say that you're writing your own networking protocols, but you probably have a very interesting way that you want to manage the fleet of switches that are involved. Our goal with this next chapter of ONL is very much to make it available to the broader group here. To say if the code that you want to write is not so much writing your own BGP stack, OpenR stack, or some other new protocol stack, but the code you want to write is some very interesting new way of managing the switch itself. The expectation for the next chapter of ONL is very much that this is still for software development teams. But at the same time, it's for software development teams that are really more concerned around the management than the protocol stack itself. So to that extent, a lot of interesting and hard work has gone into extending netlink listeners in order to use higher layer packages, but run them actually all the way through the stack, all the way down to the networking ASIC at line rate. And now, Rob, I just did the same thing that you did.
The button's super small.
Okay. Oh, thanks. So this is a demonstration of our prototype for a next generation networking stack. And it just came from nowhere, the request. So let me just stop that for a moment. I think it just stopped. Is it? Yeah. Oh, it is. OK. So basically, the setup's pretty simple. There's a top window that will be running our P4 controller, a middle window, which is actually on this console interface of the switch, and 2 windows down the bottom for the hosts. These are actually Google production hosts, which we're really happy about, because it was just yet another level of realism. Oh, do you know what you're... Let it go. OK, so This is a quick zoom, so just to say, yes, we're using ONL2. We didn't think to do the ONLP. This is actually a P4 program. Can you read it? All right. So we'll just let that scroll past. Basically, this is just one of our tests, effectively. Whoops, and I've done what everybody else did. Can't quite tell where we are in the demo. Okay. So, route injection using P4? Yep. So, down the bottom here is a P4 switch, part of our thing. We'll just get this going. Unfortunately, we sort of wrapped it up, so it's not very impressive, but basically, we didn't test full rate line traffic. It turned out it was actually very hard to get iPerf onto the servers I was using. And you dropped it at the last minute. But hopefully our short ping times will demonstrate to you that it was actually working. So, yeah, that's about it. So, actually, I'm just going to hand it off because there's really not much else to say there.
I think most of what we want to do with the rest of the time is answer questions. Does anybody want to go first?
So please help me thank all the speakers and the demos too. So, yeah. Any questions for any member of the team here? Okay, perfect. Go ahead. Go ahead.
So for that Fboss on ONL, is it already in production environment or just a demo or prototype?
So let me qualify what I mean by production. So we have our proper data center, and that's production. What we are working towards will be production, but not in that part of the network. That is work in progress. It is not. It is not in a rock and roll, let's deploy it yet state. But patches are coming around. So.
Okay. So ONL looks good, but what are the major problems you have seen when you integrate Fboss with ONL? Do you see any major issue with?
Not really. Most of the issues, honestly, have been on the Fboss side, just because there are features that we'd like to have in open source that didn't exist. Just to almost air dirty laundry, the open source Fboss has not had as much love as I would have liked it to have had, and it just needs a so I added continuous integration. I added more tests. It's getting run in different places, but I mean, ultimately that is the code that runs a lot of our production network. So I mean.
Okay, so you have your existing Fboss, and now you have Fboss over ONL. So how do you balance that? Are you plan to transition to ONL completely, or what's the plan?
So as I mentioned in the slide here, right now we're using it to bootstrap cases outside of that one security zone. We're basically, internally the project's called Fboss Lite. It's, we can run Fboss, but in a light way that's not as coupled to the rest of our network. There are all sorts of thoughts of what we could do after that's working, but I'm an engineer. Step one, get that working, then we'll figure out where to go with that.
Okay, thank you.
Can you expand on the P4 runtime, what that is and how it is different from the regular P4?
So I'm not an expert on that, but let me take a stab on it. So P4 runtime would be something like a devices forwarding agent, which would be an implementation of a P4 spec, and then which will interpret the incoming, let's say, P4 write request or any P4 program, and then program the underlying ASIC. But we can take that offline suddenly. Yeah.
I think we've got a lot of folks here. They can be available after the session. We're gonna move on. So I'm gonna have to call an end to the questions at this point. But please help me thank the speakers again. Thanks, you all.